finding the middle, okay, and the outsides of normal distribution curves. Okay, well, that's a very long title. What on earth are we talking about? So here's two distribution curves, okay. I'm going to make up some numbers just to go along with it. Again, I'm going to stick with the ones of IQ because I tend to know them a little better than anything else, okay? So I think IQ is roughly at 100 in the middle, and a standard deviation is supposed to be 20 each way. Okay, so here's roughly the standard deviation, so that would leave us at 80, 120. So that's one standard deviation, okay? So we're talking about -1 plus 1. Two standard deviations. So we just, write what we did here. We plus 20. Okay. So we're going to say standard deviation was equal to 20. And then here's minus 20. This is another plus 20. So this is plus 2 to get out here. And this is minus 2 to get out here. So this is another minus 20. And that puts us at 140 and 60. And then finally 3, which is usually enough information. 3 takes us plus another 20. So this is in the direction of positive 3 and in the direction of negative 3. And this is where we minus 20 to get our values. So does these make sense so far? Mm-hmm. So this is 160 and that's 40. Okay, so we have that information. Now for z-scores, let's say they told us we wanted to find all of the information outside of one deviation from the mean. So in other words, here's a deviation from the mean, and here's also another deviation from the mean. Well, what we need to be doing here is we need to be taking this amount, and we're looking for the amount that's to the left of a deviation from the mean, and we're looking for the amount that's to the right of a deviation from the mean. Okay? Well, we need to be looking for those amounts. So what we're really looking for here, let's scroll down, is we just need to pull this part out, and we need to pull this part out. So this is all we're really looking for, these two parts here. But the problem is, when I do this deviation, there is, no problem. It's pretty straightforward, okay? I look up my z-score, and, okay, so let's say you looked up your z-score, and one deviation, so 0.1, we already know what it's going to be. This is going to give us a value of 0.15. What was it again? 1587, I think? Mm-hmm. 87. That's how much area, or a percentage, is to the left of a deviation. And that's how much that area is there. The other problem is, though, so we've taken that part out. Okay, so let's think of it like this. We've taken that part out here, and we've brought it down so it overlaps. Great. Overlaps. Perfect. So that's our value. It goes down there. So we've done the first part. So this part's checked. We'll say check, we've done this part. Okay, we found out how much that area is, and it's there. The other part, though, because of the way they tend to work, this one deviation, it measures to the left of that value. Okay? I'm going to try to fill it all in here in one shot, because that way I'll be able to move it. It measures to the left when we look for the other deviation. This measures to the left of this deviation. And it turns out when we look at our z-scores, that's going to give us an amount. That amount is 0.8413, right? But that's not really what we're looking for. We're looking for the amount to the right of that. Okay? So if you look, what I'm going to be doing, because we know the area under the entire curve. So under all of this, do you know what the area is equal to? What number?
1.
1, that's right. The area is equal to 1 here. So know if that area is equal to 1, what we can do is, what we're looking for, this blue one here and this green one here, they actually add up to 1. Okay, I know it's not perfect there. Mm-hmm. But they add up to 1. So what we do is we subtract that amount, and that amount being this number here, we subtract it from 1 to find out what is to the right of this. So we take this number 1, okay, and we subtract our amount, which is 8413, and it turns out we're going to get 0.1587 again. Okay, now it just so happens we took identical amounts. So in other words, this area here, because we subtract, this way it would fit right into here and fill out the rest. 1 plus that green part would be 0.8413. So because we subtract it, we got 0.1587. Okay? And they end up being identical amounts. So in this case, what we got to do is we find the one deviation and the other deviation. The one deviation is the true amount. The other deviation, which is here, we have to take 1 and subtract by it. And that gives us the two outside curves. Let's pause that for a sec. Okay, so then what that means, in order to find out the total amount, remember this was just this area, and that was just this area. So to find them both out, we have to add them together. 0.1587 plus 0.1587, and it gives us 0.31 something 4. Is it 3.4? It says on the sheet I printed out. 7.4. 3174. Okay, so the total area of both of these is 0.3174, and as a percentage, you'd say it's 31.74% of the information. So those would be the outsides. That's the process of the outside. We look for one, and for the other one, we take 1 and subtract it by. But let's say they asked us to find the middle of those two. Okay, so same idea. We're going to use the same numbers just to speed things up a little. Okay, we have our deviations again. Those don't look quite symmetrical. Let's put them more like that. That looks a little better. Right, so here's our mean in the middle. Here's our mean in the middle again, and our deviations. Okay, let's say they said, okay, no, instead in this one, we want to find the middle. Okay, so if they say we want to find the middle, that means we're looking for this area under the curve. Okay, I'm just going to fill it in. So we want just that amount. Okay, so that's what we're looking for, and we'll move it down to the bottom. So that's what we're looking for. Now we're going to use the exact same numbers. We're going to look between one deviation. We already technically know what it's going to be. We already know that this thing represents 68%. Right? We already have, or roughly 68%. But when we look up our z-score for one deviation, so this is minus one deviation, this is plus one deviation. Okay, when we look up our z-scores again, in this case, that's minus one deviation. We already know, when we looked up this one to start, we knew that this area underneath the curve was 0.1587, I believe. Yeah, okay. That was 0.1587. And then, I'm just going to drag this out of the way for a second, just so you can see. So that's what that one is here. When we look up the other one, we know that this guy is 0.843. 413, yeah. So that's to the left of this guy. In other words, what that is I'll do it in purple, all of this area here. Oops. Okay. I gotta color it all in one shot so I can move it. Okay, so that's all of this area here. Well, we're only looking for the blue part, right? So what we're going to do is see this green part, how it darkens it. When it darkens it, I just want you guys to kind of look at that. Let's just look at what's purple right now. Well, what's purple right now is exactly what's blue. Okay? So in other words, from this, we need to take out, oh shoot, I hope it'll let me grab the other one. We need to take out this chunk. We need to subtract it from there.
Okay.
So what we do is we already know our purple. Shoot. Let's write him in purple. This number is purple here. So he's 0.8413. That's the purple. Well, we know the green part is 0.1587, so we'll write him in green. 0.1587. To get the blue area, we need to use the operation of subtraction, right? We got to take this green part away. We have to subtract out of it, and what that'll do, or think of it like we've shoved it here, it creates only the blue.
Yeah.
So when we subtract those two values, now that's something you can just quickly do in a calculator. 6826. So our blue is, what is it again?
0.6826.
826. That becomes our blue area. So we just subtract those two amounts. And just think of it like that. We've taken this amount out of that. And that's what creates the blue part. All right? And that makes sense because remember we'll zoom out just a little entire page. Remember we talked about purple being 68%, or sorry, the blue part being 68%. We knew it was roughly, we knew that between one deviation both ways is roughly 68%. Well, that's exactly the value we found here. We found 68.26% when we subtracted those two. Okay, so that's how you go about finding the middle part. And then, so that was our part 1, the middle part. And then part 2, part 1 was the outside part. Part 2 was finding the middle part. So it's a little bit different to find each part of those. Okay, and we use very easy deviations. We use ones that were symmetrical. They may not give you symmetrical questions, where you'll still have to find those amounts and do the same process when solving it.
Okay.
Okay.